So we're here to talk through this double Kakuro by Dan Katz. One of the things to do, particularly in these double Kakuro, but you can do it in regular Kakuro as well, is look for extreme sums, values that are either about as small or about as large as you can get. I think when I looked through this puzzle, I saw exactly 4 that were clear at the start. 7 and 3 cells is 1 plus 2 plus 4. You know exactly those digits, you don't know where they go. Just looking vertically, it doesn't seem like any of the columns force information there. We have a 35 in 5 cells. That's exactly 9 plus 8 plus 7 plus 6 plus 5. We have a 15 in 5 cells. That's 1 plus 2 plus 3 plus 4 plus 5. And I have a 16 in 2 cells, which is 7 plus 9. And I might as well just write that in as a trick, or as hints. Now, why put these notes in at the start, or why identify these? Like in an actual puzzle, I probably don't circle these, but I just want to highlight for you as a solver that the most natural starting points for the puzzle, and also where the progress will proceed, will be probably working through these clues until we place digits, and then we'll go to new places which are also extreme values. That trying to look just, for instance, in these bottom rows, there's nothing that's very forced here. Like I know a 9 is in one of these 3 cells, but I can't do more than that. I know that these values are just between 1 and 4, but I can't do more than that. And so the extremes are where the break-ins to the puzzle are. There are actually 2 break-ins, but one of the first is this very center cell. We see the overlap of the regions I've highlighted as this cell. We said 15 was 1 to 5, and 35 is 5 to 9. They intersect just in 1 digit, which is that digit 5. We can then actually make some constraints on the remaining cells. So these clues have to interact. This can only be as large as 3 or 4 to go with a pair of 8 or 9. If, for instance, a 6 was in here, that wouldn't work. A 7 here, put another 5 in there, that wouldn't work. Similarly on this side, this has a limit of 6, 7, 8, which gives us a 1, 2, 3. We can do sort of light things like this. The other break-in that was there at the start has to do with the 16 clue in 2 cells, and has to do with this 5-digit 18 sum. In 18, the largest potential digit is an 8, and so at the start we could have said that we knew the 9 goes to the right and the 7 to the left. Now that we actually have both the 7 and 5 placed, we have 6 remaining in these 3 cells, and so if we actually just circle cells that are now sort of easy to fill, these 3 we now know are places to look at, and specifically look at the set 1, 2, 3. A digit 1 can't go here. If a digit 2 goes here, it gives another 9. So the next logical placement is this, and we get a 1, 2, 1, 2 pair. We can look at these 3 digits which sum to 22 and get a 1, 3, 1, 3 pair up here. The next break-in is a little trickier, but is going to come from some of these extensions we've placed. I'm going to look down here at this one, and particularly I'm interested in this clue now, because a 30 in 4 cells is 9876, and what I'm getting is a very, very tiny sum with it, a 1 or a 2. So this is going to be at least a 28, but more likely a 29 in these cells. Looking across, the 17 down has a lot of values. 36 is flexible, 22 is flexible, but this 6 is small, so this has to be 5 or less. Actually, in this case, it has to be 5 or 4. 3 would be too small, and if it's a 1 or 2, this would now be very tiny, and we wouldn't get an acceptable sum over here. And this 5, 4 makes another 1, 2 here. And we get the nice deduction that I think Dan had in mind in making the puzzle, which is that we have this pair and that pair, which mean that these are the same digits. If this is a 1, this cell is a 1. If this is a 2, that cell is a 2, which means that these 2 sum up to 6. However, they're placed. That makes this be a 7, 8, 9, 7, 8, 9. 7, 8, 9 to finish it out. We didn't actually mark it up above, but this is known to be 6, 7, 8, 9. And now the next tricky deduction is probably looking at the 17 coming down. Notice that the minimal value it can take is 6 plus 7, which will leave 13. The next largest is probably 6 plus 8, 14, which would have a 1, 2 in the remaining cells. So all these values with 9 aren't possible here. And even the ones that use like a 7 up here would force an 8 here, that would be too large. So the 6 doesn't go, 8 doesn't go. To be small enough, we can get that this cell has to be a 6, and then this will be a 7 or an 8. And then the next step is to think through the remaining placements. So if this is a 7 or 8, the remaining digits will be 1, 2, or 3. If I think about 1, 2, or 3 down here, I have already used 1 and 2 in this row, and that gives us very nicely, this has to be a 3. The remaining digit is a 1 with a 7 as the minimal set. And we get those placements to fill out the corner. The 3 working off this clue gives another 7. 22, as we said, always has a 9. Once we place a 7 in it, this is going to be 9 with 6. So the only way that makes sense will be like this. This will be the 8. We can now start to think about the vertical clues. There are actually 4 clues which use 7 cells. This one, this one, this one, and this one. And it will be important in each of these cases to identify the 2 digits which aren't used as a pair that sum up in this case to 45 minus this clue. So the pair that's missing here add up to 9. 9 can be 1 with 8, 2 with 7, 3 with 6, or 4 with 5. And so 4 with 5 is missing. The remaining digits are 1, 2, 9. 1, 2, 9. If I look at a cell like this, only 9 works. That gives me 1, 2, 1, 2. I'm thinking back to my 7 clue, which needs a 1, 2, 4. The 4 has to go here. Get 2, 1, 2 as a way to fill out the rest of that clue. Let me just do a little more cleanup in the center here. We have now this has a 7, 8 option only. This is a 7, 8, 9. There's another break-in which goes a little like the circle around here, and it has to be on the right side. Again, we said that these highlighted cells are places to look, so this is a cell that's in a space we haven't looked at yet. We can first just sort of mark its extreme values, so it's 4 or smaller. I use this notation to look at something like that. And this clue is 5 or smaller off the 6 sum. And in the same way we had constraints build up from the 17 once we had 2 digits in mind. Over here, we're going to have constraints build up from having these 2 digits in mind for a 25. What do I mean by that? So if this is a 5 and this is a 4, sort of the highest value, that leaves behind 16, which is a 9 with a 7. So these remaining cells are either 9 with 7 or 9 with 8. The 2 potential values will be to leave 16 or 17 as the total remaining value. That actually gives us the fact that this has to be 4 with 3. This can't be smaller than 3. It also can't be a 3. So this has to be 4 or 5. Once I actually write that, if I put in a 4 with a 3, that's too small of a total sum. So the actual digit I know for sure is this is a 5 with a 1. This can be a 3 or 4, but it's going to fill out the rest of the set to leave behind 17 or 16 as the critical sums, as we mentioned, to get a total valid potential. This 3, 4, 3, 4 actually now marks that as a 1, 2 pair. It's not immediately helpful, but we can at least plant this seed and use this to ultimately get onto the side. What I'm going to do now is actually come back to do some cleanup that we hadn't done, which is we made some progress in this row, so let's look at the rest of this extension. The first thing I see is this 5, which has very few options left when the 1, 2, and 3 are already accounted for. It has to be 4 with 1, gives this 2, gives these digits here. Now, as we did down here, let's do it again over here. Let's find the missing digits. They add up to 12. The options are 3 with 9, 4 with 8, or 7 and 5, and the only ones that aren't accounted for in part are 7 with 5, which leaves behind a 9, 8, 9, 8. This would then become a 4 or 5. This would then become a 6 or 7. So the next place to look And here again, I'm just jumping around the grid. Some of it is that we got a lot of break-in at one time by getting this whole column, but we have to come across in both cases, is to look at a clue that's paired with this one, this 5 up here. 5 clues can be 1 with 4 or 2 with 3, but having filled in this corner cell, we now get a nice deduction, which this is a 1-4, 1-4 pair. We don't know which is in which site, but whichever is used, a 1 will be in one of these cells, which cancels the option for a 1 in this cell. Puts a 3 in here. We should now think about these cells with the remaining sums. This is 5 with 8 remaining. 4 plus 4 isn't going to work, but 1 with 7 will work. Now have just an 8, 9, 8, 9 here, which makes this a 7. It's a 2. So 1 coming over. Let's come back to here and just think about the total sum. This right now is 13, leaving behind 15. 15 is 8 with 7 or 9 with 6. 9 with 6 is the only one that can go in the grid. We can now come across, just as with the other long clues, what is missing from here. 2 digits that sum up to 10. That can be 1 with 9, which looks like it's still possible to be excluded. It can be 2 with 8, it can be 3 with 7, it can be 4 with 6, and those are all the choices. So 1, 9 is the option that's not possible. That takes us to an 8, 7 over here. Notice that we commented that the sums would be 16 or 17 for the remaining cells. Both of those require a 9. So now that the 9 is known to not be up top, the cell has to be a 9. And something that can help us now is we actually can solve out the remainder of the middle and see that the actual scenario is that this is, for this full sum, an 8 up top. The remaining digits in this space are a 7 and a 5. So we have a 4, 6. We have a 4 up here. 4, 5 with 5 is bad. 7 with 3 is okay. We have a sum of 19 so far. We need a 5 to finish it. This 8 helps us clear out this bottom cell, which we marked before. Here I'm just putting in things I know. What's missing from this group? We have a missing sum of 9, 1 with 8, 2 with 7, 3 with 6, 4 with 5, 2, 7 is what's missing. So the remaining digits are 4 with 6, that's a 5, that's a 3. Just check the sum matches 23, that looks good. And we finished this challenging puzzle. The key things, I think, which apply to all Kakuro are to really look for the extreme clues and keep a mental map. I don't know if it's helpful to circle them or kind of shade them or just write little numbers into them when you know them, but however you notate where the extreme clues are, those are really where the seeds of the puzzle will sit, and we saw that there were a rich set of extreme clues in the middle. They intersected here, and we've built out from there. The things that were more specific to this puzzle were some of the cool steps. I really like this the 6 clue that gives a 1, 2, 1, 2 pair. These 5 clues had some good deductions in the middle once we had a little bit of knowledge about the digits around them. So it had a somewhat narrow path to get from this middle out and over to finish in the side, but a very enjoyable double Kakuro to close out the week. And if you enjoyed this style of puzzle, you'll have a lot more challenging double Kakuro in the upcoming Art of Puzzles 2 book. We'll see you again soon.